We're going to be looking at graphing inverses today. So let's look at the following definition. An inverse relation, a relation that interchanges the input and output values of the original relation. Basically, the domain and range are a switch. Another way of thinking about this is that we're going to switch the x and y values. So look at the following function. It's just a function made up of 4 points. Let's graph them as we look at them. So we have 2, 3, 0, 5, negative 3, 1, and negative 2, 4. Alright, now we're asked to find the inverse. This notation, that means find the inverse. So we're simply going to switch the x and the y. So 2, 3 becomes 3, 2, 5, 0, 1, negative 3, 4, negative 2. Alright, I'm going to switch colors, and we're going to graph those inverses now. So we're going to graph 3, 2, 5, 0, 1, negative 3, and 4, negative 2. We're looking for a relationship. Well, I hope you notice that the mirror images of each other, and that the line of reflection is the line y equals x. This is always true between a function or a relation and its inverse. The line of reflection is always going to be y equals x. So here's a couple examples of that you don't have on your paper. So we have f of x and g of x. Notice the line of reflection is y equals x. And then we have the function f of x and its inverse, and the line of reflection is y equals x. Alright, you're asked to draw the inverse of each function. Alright, so the way we're going to do this, the way I like to do this is I pick points. So I'm going to pick points on my original graph. The more points I pick, the easier the flip's going to be. The more set up front, but the easier the flip's going to be. Then write down the coordinates of those points. So I have, what, negative 2.5, negative 4, negative 2, negative 2, negative 1, negative 1/4, 0, 0, 1 1/4, 2, 2, and 2.5, 4. So write down the coordinates of the original. Alright, I'm going to change colors because I can. And I'm going to flip them. So I've got negative 4, negative 2.5, negative 2, 2. I always take the time to write down this step because I find that if I try to do this in my head without actually writing it down, I'll end up graphing the wrong point. Alright, now let's graph the inverse. So we've got negative 4, negative 2.5, negative 2, negative 2 didn't move, negative 1/4, negative 1, 0, 0 didn't move, 1/4, 1, 2, 2, and then 4, 2.5. Alright, let's connect those. Alright, now remember, a visual check is to see if the line of reflection is that y equals x. Check to make sure you graphed it correctly. Notice that the points that are on the line y equals x don't move. Alright, now we were asked, is the inverse a function? Well, the original is a function, so we can give it function notation, say g of x. And the inverse in this case also happens to be a function, so we can call that the inverse of g of x. Alright, let's look at one more example. Alright, notice here again we have a function. We can call it h of x if we want to. Alright, pick some points. Write down the coordinates of those points. Now the coordinates of those points. 1, 1, 2, -2, and 2.5, -4. All right, here again, we're going to switch them and regraph. -4, -2.5, -2, -2, 1, -1, -1, 2, 0, 1, 1, -2, 2, and -4, 2.5. All right, let's regraph. So we're going to have -4, -2.5, -2, 2 doesn't move, 1, -1, 2, 0, 1, 1, -2, 2, and finally -4, 2.5. All right, let's graph those. All right, is the inverse a function? Well, no, the vertical line test fails, so the inverse is not a function, so we don't give it function notation. The best we can call it is a relation, but it doesn't get function notation. All right, if you have any questions, let me know.